Welcome to this video. Today we will be benchmarking the latest VLM from Mistral AI against GPT-4 on several datasets. Join me as I guide you through this process, showcasing the true potential of this model, which could even become your next image-to-text solution for your application pipeline. Before we dive in, this channel offers weekly content including LLM guides, tutorials, and concept videos. So if you enjoy this, consider subscribing and giving a video a like. So, what is Pixtral 12B? Last week, with the most weird way of announcing a model, Mistral AI introduced Pixtral 12B, their latest vision language model in form of a torrent magnet link. Now, I for one was confused, except from the obvious fantastic opportunity to come up with the most hilarious name for a model. Why should we care about a 12 billion parameter model? When Coin just released their 2 billion and 7 billion VLMs last week. Pixtral 12B excels in understanding complex visuals such as charts and diagrams, a task where the other VLMs lack depth and contextual understanding. This power comes from a new 400 million parameter vision encoder, which processes images at their native resolution and aspect ratio, eliminating the need for image pre-processing. Additionally, the model has a large context window of 128,000 tokens, making batch inferences easier. For example, it can process up to 2000 images in one go. Pixtral follows a straightforward design with a multi-model transformer decoder that houses the vision transformer encoder. Let us hear about the model architecture from the model itself. Now that we know more about the model structure, let me share some interesting facts about its capabilities. Pixtral 12B excels at extracting detailed insights from complex visuals, including charts, graphs, and diagrams. Its advanced vision encoder enables it to interpret things at their native resolution and aspect ratio, making it well suited for applications that require precise analysis, such as scientific imagery or intricate schematics. Pixtral 12B stands out with SOTA performance in image-to-code tasks. It can easily analyze visual elements and generate corresponding code, a valuable capability in fields like software development, design automation, and even machine learning. By understanding visual end patterns and translating them into functional code, Pixtral 12B offers powerful assistance in automating tasks that traditionally required manual input. Pixtral 12B supports multi-image inferences, allowing users to input several images at once for comparative analysis or joint reasoning. This feature makes it ideal for scenarios that require a holistic understanding of multiple visuals, such as medical imaging, video analysis, or storytelling through sequential images. The model's ability to process multiple images simultaneously enhances its versatility and efficiency in multimodal tasks. Now, as of the time of me editing this video, Mistral AI has released an official press release about their model. So let us see what did their own benchmarking stands. Moving on to our own benchmarking, we will be evaluating the model on the following dataset. ArxivQA. This dataset consists of research paper-based question answering tasks with GPT-4v inferences. Visit VL Benchmark, a dataset containing real-life VLM applications, also comes with GPT-4 inferences. And finally, Flickr30K, a long-standing image captioning dataset with GPT-4o inferences available for comparison. For evaluation, I chose cosine similarity to measure the semantic similarity between the text and the references. This gives us metrics such as win rate, where performance exceeds a threshold, and top 1, 5, and 10 average cosine similarities for both the inferences and the predictions. Now, due to the size of the model, I use TuneStudio for running inferences. They generously offer unlimited API calls, and using their native GPUs, I averaged about 350 plus instruction inferences per hour and 500 plus image captioning inferences per hour. Now let us dive into the actual benchmarking results. For the ArxivQA dataset, I used 1000 randomly selected images from a pool of 100,000 images. These images come with questions related to various research papers, presenting a strong challenge to the model understanding of scientific and mathematical principles. These questions are paired with 4 options which have the potential answer, with the final objective that we are looking to achieve being given by the correct answer, and label for each question and comparing it back to the results GPT-4v gives us. The comparison between the labels generated by the model and the reference shows a lower win rate and top scores due to the model's tendency to return multi-word answers, which increase the sample size, thus decreasing the percentage. However, the rationale score consistently shows high top accuracy. Next, visit benchmark, which consists 500 images from a real-life situation where VLMs could excel. Human and GPT-4 captions are provided for captions. The model's task is to generate instruction-based responses from the images. Here is a sample data point from the dataset. Here you can see the GPT-4 prediction is answering the instruction, and the instruction condition caption is simply explaining what is going on in the image. The objective of the model over here is to answer the instruction based on the image provided. And in a similar fashion, we shall compare the win rate and top scores against human captions and GPT-4 instruction captions. Compared to human captions, the model shows a lower win rate due to more expansive descriptions provided by humans. However, when compared to GPT-4's instruction captions, the model shows significant improvement, showing strong instruction following capabilities. Finally, we look at Flickr30K Benchmark. If you were associated with those hard coding computer vision back in the day, you might remember this model, which holds about 31,000 images which come with 5 potential captions. However, for the sake of this experiment, we source a rather new version of this dataset available on Hugging Face, where the user has generated GPT-4o captions to go with the original image. Here is a sample from the dataset. The objective of the model over here is going to be generating captions for 1000 images chosen at random from the dataset and generating captions describing the image and comparing it against the human generated captions and GPT-4o generated captions. While the model scores lower on human generated captions due to its more objective and condensed outputs, it performs similarly to GPT-4o generated captions in many cases. Now, in conclusion, Pixtral 12B holds its grounds against SOTA models in almost every task. Despite being smaller than the other models, it proves to be a faster and more cost-effective alternative to GPT, Gemini, and Claude VLMs. While its creative reasoning may not match with other models, its cognitive and analytical abilities are solid, consistently achieving assigned tasks with ease. Since this was my first time benchmarking VLMs, I relied on Google to find these benchmarks. If you know any other interesting datasets I should test Pixtral or other VLMs on, please drop a comment. Finally, I'm starting a GitHub repository where I'll be sharing the code to benchmark Pixtral and other lightweight VLMs. Be sure to start the repo and stay tuned for more benchmarks.